We have sound? Probably. Okay, let me just get my notes here. Okay, so good morning, good afternoon, welcome everybody. I'm going to talk a bit about Boomerang today. My name is Mattijs Meiboom. I'm working at bol.com for about 3 years now, and I'm a software engineer in the fulfillment space. They're sitting over here. Welcome, guys. Started out in the area of logistics via bol.com. Nice project, but since about 8 months, I switched to T21B. You can find us at C4, and we are working on Boomerang, and that's what I'm going to talk a bit about today. Now, Boomerang is about 6 months ago. We started working on it. It has been released in production, the first parts a couple of weeks ago. So this is a nice time to look back a bit about how we set things up. I hope to give you some ideas for your own services maybe. Not here to convince you of the one and only way you should build your service, but more about the process we had and how we did things in the end and what that did for us as a team. We're short on time, so I will be cutting some corners, but feel free to find me afterwards and ask some questions, or otherwise we are on C4. So, and there are some resources at the end as well if you want to look stuff up for yourself. Okay, but first I'll start with some context. As I mentioned, about a year ago we started getting the green light for Boomerang, mostly because of the back office project. Now, for who don't know it, it's about getting rid of the monolith LSM, the big Oracle monster, and one of the services running on top of that is the after sales service, which is currently handling all the returns for bol.com, and it's blocking most of the innovation we can do. And the returns process can really use some innovation. So once was said, okay, let's replace this. We're gonna build a service for this specifically without LSM. Business got wind of it, and within days we had a roadmap for the next 2 years. So that's when the joy starts of prioritizing and fighting. What are we gonna do? And somebody said, guys, we're first going to replace this service, which is difficult enough already. So it was a bit of a hectic time, and we had to make some choices, come up with a plan. So what do? Well, you go on a holiday. Recommended. I would have loved a picture here of me snorkeling. I see we're not on full screen, so let me fix that too. But I couldn't fit that into my story. So instead, a picture of me on a beach, and what I like to do on a beach on holiday. Some might like it, some think I'm crazy, but I like to read some books, and then specifically IT-related books. Yeah, I hear some laughter. That's okay. Anyway, I recommend it. It allows you to zoom out a bit and not think about your daily stuff, but get some new inspiration, a bit of new ideas. And while lying there and reading some stuff, you start to pick up on some things. You have some, I recognize this, and maybe we should do something with that. And parts of a plan started to come together, and it's good to have a plan. So otherwise you might end up in a situation where you just start doing something completely different and it becomes chaos. And we did already know about some of the challenges we would have. We were going to start with a team that was already a bit together, but was going to change a lot. An Oracle developer going to Java, a tester going to have a much more technical role, needing to do some Java stuff as well. We had some open spots, so there would be new team members over time as well. So one thing that we would probably need is to have some common ground, some structure to fall back on, to get started quickly, and in case of problems or change of plan, to use as a basis. So I'm not going to talk about all the details of coming up with that and all the difficulties we might have, but instead I'm going to pick out some of the aspects and then show you how we solve that from the structure of our application and how it helped us. So what we wanted in our plan is something to provide structure in the code base, especially for the developers. Something that helps us to develop and test and everything in isolation, because, well, the back office program, I think, Marcel, about 15 teams are 22 teams, 22, are involved in, at the same time, trying to get their stuff out of LSM, and you're going to be in each other's way. So isolation is a good thing then. And we wanted to protect ourselves against those 22 teams and the other scary outside world and all the demands we would have, and to have at least some defense there. So what did we do? We did a lot of things, but two things I'm going to highlight. We used an architecture within our application. It's called hexagonal architecture. There are variants of it, whatever you choose, but this is the one we used. And this was the one I encountered while reading a book. This book, that's the one I was reading on holiday. And the other thing we did was we tagged along on the test autonomy project. It's one of the pink elephants in IT. And one of the aims there is also to make sure that you are getting your application to production in isolation as fast as you can, autonomously, without getting in each other's way. So that already sounds a bit like, okay, this is something we want. And now if you don't take anything of the stuff I'm going to tell you in the next few slides, that's all fine. It's still recommended really to read this book at some point. It's not just about architecture, it's hardly about architecture, but it's a lot about driving the design of your application, and I found it a good read. I'm going to start with hexagonal architecture and link it to the stuff we needed. And at the end I'm going to come back to test autonomy and how that fits together, which is surprisingly well. But first, let's start very basic. Layered architecture. We have a couple of layers. Each layer abstracts the one below, and it provides some service to the one above. And it is, I know it's pretty old school and probably your service doesn't have such a structure. But this is the way applications were mostly built when the other styles got more popular. And one of the issues here they saw was that the domain is yet another layer. But instead, I would argue that that is actually the most important part of your application. And as such, it should be the core, like the center. And it's not abstracting a database. You might not even have a database, or you might be using some other dependencies below your applications. So this whole concept of layers is a bit strange. So instead, what they were saying then is, okay, let's put the domain as the thing everything else depends on. And the domain doesn't have to know about this whole outside world. It's all technical detail and dependencies, and let's isolate it. So that's the key point. We're inverting any dependencies. The domain is in the middle. So let's also get rid of the layers then. Just put it next to each other. Doesn't really matter. And of course there are other stuff you need. There may be some services. We usually have some public API instead of a presentation layer, at least if you're building a service. You might have some API specifically for your testing, messaging, what have you not. FTP is quite common within logistics. So they're all around our application, and as I mentioned, we want to be a bit isolated, defended from that outside world, so we also have some layer of defense. I hope by now you know why they call it hexagonal architecture, but the number 6 doesn't mean anything. It's just saying there could be any number of outside dependencies. So we have a boundary, we have an outside world, we have our inside domain, and we need some way to traverse between. And the part that handles that is really the rules you use in your code. For example, this is the typical way, is to have some interface, usually called a port, like maybe a use case style named thing like register, return, something functional at least. Your domain implements that functionality, and you have some way of translating from, in this case maybe a REST call, to your domain. And that translation is often called an adapter, which also explains the alternative name of this structure, which is ports and adapters. Maybe you've heard of that. But anyway, your domain, that's the golden rule, never ever knows about what's around it. We don't care. It could be protocol buffers or SQL, or you could use a box client or AQ, or whatever you use, you basically have this. You have your stronghold, which is whatever probably your product owner or your stakeholders from business want. It's guarded, protected, well preserved in this case, a nice mode, but you can't enter except for one very strictly defined port, unless people start bringing siege towers or stuff, but you might want to talk to your team then. So we're good in time, so I'm going to give a quick example, which is about job scheduling. It's one of the things we do in Boomerang, is to grab FTP files from doc data, telling us what items they got. And it's quite technical. You have to create an FTP connection, and you have to do scheduling of that job. You want locking between nodes, and that's all technical framework stuff, and it's probably not something your product owner will ask from you. He will probably just say, I want to get a file from doc data and know what returns were received. So functionally, you don't want that in your business domain. It keeps things a lot simpler. So you define a port. You just say, okay, there's this get a file job or get a feedback object job, whatever. You can run it. And when it runs and you can test it, it should do something. And at the same time, you could have some other port that you rely on from your domain, because you still need some scheduling. So you have some other port defined where you can say, okay, I'm a job, schedule me, and just get it done. So then the inside of your application becomes quite straightforward. You just have your business functionality, and you do some delegation, but there's no frameworks in here whatsoever. And you can test this in isolation, offline if you want. You can write your cucumber tests directly against these interfaces or some other feature or acceptance tests, what you like. But you don't care about the technical stuff here. And then on the other side, you still need to obviously handle that stuff somewhere. But you isolate it. For example, you have some scheduler that is able to do distributed locking between nodes, maybe Hazelcast, and it's able to do some scheduling, RxJava, for example, or something else, what you choose. But the key point is that we've separated the technical stuff from the functional stuff, and we've made our boundaries very explicit. And we've set ourselves up not only for, imagine you're just starting with Java and you're wondering what should I put where. So you've created some structure at least to guide you in that part. But we've also gained something else, and I'll illustrate that next, as a part of test autonomy. Because as I mentioned before, what we want is to develop our stuff in isolation. And we want to have fast tests with fast feedback, independently. Don't do the whole fitness stuff anymore. Don't wait for a test environment, but just develop locally. So what can we do about this? Well, we probably have defined some types of tests we want to do, and we would like some structure there as well, to have each type of test cover some certain responsibility and help us in the best possible way to go fast. So I'm got a bit more elaborate example for that. This is basically the same structure, only there's more stuff now. We have more business logic, we might have a database, an external server, FTP again, and some technical adapters in between. And we can have obviously our unit tests. I hope you're doing those, and probably just put them on a single class. Not much special there. But the next one is interesting, because if you have acceptance tests, and with that I mean tests that cover your functionality for your business stakeholders, you can test exactly against the boundaries you have defined before. Your tests use the ports. Those are the only entry points into your application. If you can't test your functionality without those, then you're doing something wrong. And on the other side, your application depends on some other dependencies, a service, whatever. And you can stop those from the outside, from the port that expects some adapter. So you cover exactly the boundary of your functional domain, and you can't break that unless you're bypassing your own rules. Well, you can always do that, but I hope you have some code review or other structure in place for that. So that's a very strict boundary for doing your tests. And the same pretty much goes for your integration tests, except now you want to cover your technical layer, your adapters. So again, you have a very specific boundary. You have your API endpoints, where you can talk to with a driver or HTTP or whatever your protocol is. And you can spin up any dependencies that your application expects in a Docker container, or you start up a local FTP server, box in a standalone client, whatever you expect there. And your integration tests only talk against the interfaces of your application and the interfaces of those containers you have running. These are slower, but it's pretty specific what the goal of these tests is, which is only to cover the adapters in your application. And this is also where you could do stuff like resilience or mimic slow network connections, because the Docker containers are actually connected to your application over the network. So together you have pretty much everything covered. You have your functional in the center, integration adapters on the outside, but each part has its own responsibilities, and you can keep the inner parts very fast, mostly because you don't need to spin up all those dependencies. And what we used to see in some of the services we worked on, and also the ones that I built, is that it used to be a one mix of everything in one big test suite, and it becomes slow, and you don't know what to put where anymore. So this addresses that as well. So in the end, is this perfect? Is everything awesome? Well, for us, for a large part it is. I mean, it gave structure, and one of the feedback points that our colleagues that started later gave was that it was very easy for them to find where to put certain stuff, where to find stuff, especially compared to the old service we were building. And also for testing, it's sometimes getting used to, but it's pretty clear what to test where and what the responsibility of each part is. So this common basis to fall back on during the more technical discussions is very useful. One of the things we also noticed is that when our service started to fail in test environments, it usually was because of assumptions on how you should stop something, and not on how we implemented functionality, because that was already tested and accepted in isolation already. And we hardly had any findings in that area, unless you misunderstood your product owner. Maybe that could be an issue. But at least what was built was working as we built it. So there's a lot more detail you will have to think about. For example, the inner business logic, you don't put everything in one big package. You probably want to have some more structure there. We use package by feature, but it's a bit too much to go into all the details here. Instead, some resources, some blogs continue on this architectural style, and also on the way to test it online. One of the other engineers here, Oscar, has wrote a Techlab blog, which goes a bit more into details about the internals. And you can find a lot on the test autonomy and the goals of it on Confluence. Next week, or maybe it's not yet scheduled, so there will be some communication about it. But our tester and myself will talk a bit more about this from a test point of view, go into a bit more detail there. So if you're interested in that, I recommend you go there. And that's what I wanted to tell you for now, at least. Again, if you want to have more detail, come find me. And otherwise, ask a question. I want to thank you for your attention. And we have 5 minutes. Yeah, 5 minutes.
Any questions? Hey, great presentation. Really liked it.
Thank you.
I was wondering, the Docker containers that you spin up for the integration testing, are they like a snapshot of an application?
You mean then the inside of our own application, right?
No, I mean
Or
the external service. Like which version of the external service is
okay. Yeah, if a team provides their container, maybe you could use that. But we only want to test our integration layer and the adapters we wrote. So there's some assumption about how that service behaves. We use WireMock to spin up in a Docker container, and WireMock has an API as well. So you can, let's say it's here, you can instruct the mock to respond in a way that we assume, and then test at least our service against those assumptions. That's also a reason why the failures we've seen are usually about those assumptions, because you're making them. So you still need to think about that part, either through end-to-end tests, but those are slow and painfully in feedback. So we only have happy flow, about 7 fitness tests against 150 before. And I know that some people are looking into using contract testing on the side of the downstream application for that, but we haven't gotten to that point yet.
As a follow-up to Rico's question, so you spin up a Docker container that basically simulates your assumptions of the external service. Is that also part of your code base? So that, well, if you deploy a version, it happens out to fail, you can quickly say, oh, my assumptions were wrong, and here is where they're coded.
Not those assumptions. Well, the integration test on a separate module, so we build our application, deploy it locally. But you're still testing your assumptions, and if it fails, then you need to still contact that team and figure out where you've gone wrong. The only way to find that is either you're getting some issues later on in production, hopefully before, or your end-to-end tests or other logging might somehow give you a hint about those. Or, well, contract tests are one of the usually mentioned ways to do that, but can't speak from experience there.
Anybody else? Yeah.
Yes. My question is, so is there like a physical boundary somehow, or like does the middle part, is that like one jar, or and the other parts, how are they deployed or stuff like that?
Yeah, to some extent. We're not using Java modules or stuff like that, but we have one technical package, which has all the adapter clients, all that stuff. And besides that, we only have functional packages. So everything in the business logic is inside those. You don't have any dependency from the functional package going into the technical package. Yeah, you have to enforce that somehow, either static code analysis or code reviews, or just search through your packages and see if there's any imports. At least the way we've done it. I guess Java 9 modules, maybe you can split those off a bit further, but yeah, that's how we do it, at least for now.
I was trying to wrap my head around the acceptation test layer.
Yeah.
Can you elaborate on that a little?
Yeah. So
because unit test I understand, and the integration test from the outside, I also can imagine that. But
yeah. So what at least we've done is you have in the end the feature you're trying to build. We write some cucumber tests either up front or a bit depending on how technical the feature is. Sometimes more in parallel. But that's the functionality you're building. You're expecting the inner part of your application to provide. So that means it's on the inside part. You need to use that functionality. That you should always be able to do that via one of the interfaces you've defined on that boundary.
Yeah.
So you should always be able to, if you spin up only the insides of your application. We use a partial Spring context that only has domain classes and stuff, and not of the dependencies, so it's reasonably fast. But then you should always be able to write your acceptance test against those interfaces.
And do you mock your dependencies in that.
Yeah, so then if there's, let's say there's a database dependency here,
Yeah.
then normally in the technical layer you would have an implementation of that interface, like some SQL Postgres or maybe an in-memory stuff. But during the acceptance tests, we either have a mock for that, you instruct the responses, or you could write a bit of a simplified stub for some functionality. Depends on your use case, I guess.
Thanks.
I was wondering, do you think it is, to what extent is it feasible to move your already built application, like you've been working on ASE, and I especially tell you ASE, into something like this? Because, you know, ASE evolved over time, then it ended up where it was.
Yeah, for ASE, no. That's there was first a plan to actually rewrite ASE or parts of it, or just untangle. There's so much entangled there that's not going to happen. There's interface objects from the the protocol buff stuff going directly to the database mappers, and it's all interconnected. So no. You could, it depends on your application. Maybe at some point at least start putting interfaces in between and try to move your drivers and your converters for protocol buffers, or at least outside of your functional part.
Are you
But
then
it's gonna be
also
tricky.
are you then also sort of suggesting, because you went over some design process and then you came up with this, probably not on the first day, but are you advocating a sort of technical design process before starting building a service? Because I think we often are very agile, like start today and see where it ends, and then you will probably not have.
We've learned some lessons on the go as well.
Sorry? Yeah, also.
Well, that helps you not just dive in from one project to the other and just start coding right away again. That I recommend it. But yeah, you have to talk to your manager. No, it depends on how long you want to take. I wouldn't go in weeks over how we're going to structure it. What we had was a 2-week sprint 0, where we only did, let's get an empty application, but with all the tests running at the right point in time and grouped together. And well, at some point we had to refactor a bit, but at least get it structurally near what we think we should have, and not do anything functional yet, except maybe a very simple CRUD get item, just something you don't care about functionality that much yet. So that was what we did. We did come back to that part over time, but
Not big upfront designs.
no, I wouldn't.
One last question. Anybody? Oh, we have two. Okay, 2 quick questions.
Mattijs, I'm not sure I understand correctly, but you still have end-to-end tests, right?
Yeah, we have no, we have 7 now, and I mean you still have to check your firewall, if you have your generated global stuff running.
After you roll to
course.
production, yeah.
Yeah, you want to do that before. So yeah, we have those, but it's only happy flow and very limited, and they're still fragile. So yeah.
What do you still unit test? Because when I look at this model, I see that the main advantage is just doing the acceptance test, and you're able to refactor your domain model as much as you like, and you still be able to run your tests.
You could do that. I think there was some discussion about that in the test channel also recently. About just there are people who say only test the outside interfaces and don't care at all what's going on inside. Personally, I still think that your unit tests also help you assign responsibility for your classes in your domain, so that you still want to just cover those. We unit test each class within the business logic, and most of them in the technical layer. So I'm not going to advocate here or say that we have 100% coverage of at least class coverage, but we still do that because if you can't really unit test your class, then maybe you should also think about splitting up some stuff, or it might also be a code smell there. So it still helps you just drive out the design on a technical level or more separating responsibilities. But yeah, some people argue the other way around. So there is an interesting read about that somewhere.
Okay, thank you very much.
You're welcome.